It's the most common form of public transportation there is, the elevator. All over the world, elevators carry riders of every age, and passengers assume their ride will be a safe one. In fact, thanks to strict and ever-changing codes as well as many devices designed to protect passengers, elevators are the safest form of transportation in the world today. Since the early 1850s, elevators have been equipped with a car safety to prevent the elevator from free-falling in the event of a hoist rope break. An added benefit of this safety will also prevent the car from overspeeding in the down direction. But if the elevator car is not fully loaded, it usually weighs less than the counterweight, and in case of a malfunction, will actually fall up. In fact, it's more common for an elevator to fall up than down, and may actually leave the floor with the doors open. Until recent years, devices to protect against these potential catastrophes were relatively unheard of. Many articles and discussions have targeted the need for protection against injuries caused by cars leaving the floor with the doors open and overspeeding in the up direction. Today, safety codes in Canada and Europe, and soon in the United States, require that all elevators in new construction be equipped with an emergency brake system that will prevent overspeeds in the up direction, and some to stop the car when it leaves the floor with the doors open. Several tragic accidents have happened due to these types of occurrences. So, it would seem extremely prudent for safety-conscious building owners and contractors to employ such a device on any elevator, whether a new or existing installation. Several devices have been developed in the hopes of preventing such accidents. One of them is the traction shiv brake. This device employs a frictional plate located underneath the traction shiv. When the car overspeeds in the up direction, or if the car leaves the floor with the doors open, the frictional plate comes in contact with the traction shiv and is then pushed sideways in the direction of travel. This causes a wedging action, applying a braking force to the traction shiv, stopping the shiv. Another device is the bidirectional safety. The down direction safety is activated, as it always has been, by the governor. When activated, the safety jaws clamp the rails, stopping the downward motion of the car. Designed to stop the car in the event of free fall, this action must be stronger than the up direction. The governor design for the bidirectional safety will also activate the up direction safety, which consists of a separate set of jaws. If the car would leave the floor with the doors open, the governor is held in place, allowing the governor rope to set the safety in the proper direction, with the jaws clamping the rail, stopping the car. A third option is a rope brake. In the event of an overspeed or car leaving the floor with the doors open, a rope brake would grab the ropes and stop the car. At Hollister Whitney Elevator Corporation, along with our sister company, GAL Manufacturing in New York, we've created a reliable, inexpensive emergency rope brake system called the Rope Gripper. Our primary objective was to design an emergency rope brake system that would operate under all conditions, eliminating the danger of slipping traction. In addition, a rope brake would not cause any undue stress on the machine, and being located in the machine room, would be totally accessible and could be conveniently tested on numerous occasions. Since the rope brake could set or reset without movement of the car, we could apply it during a power failure and have it automatically reset when power was restored, not requiring a technician to be called to the site to reset. This eliminates the need for battery backups, but would also require a technician to reset the brake if there was an actual emergency overspeed or if the car left the floor with the doors open, to determine the reason for the gripper to activate. During the development of the rope gripper, the Hollister Whitney GAL team worked to anticipate a wide range of situations that would not only meet current safety standards, but also accommodate future safety requirements and conditions, such as how a braking system would operate in the event of a power failure. The rope gripper will grab the suspension ropes to stop the elevator in the event of numerous failure conditions, including overspeeding in either direction, or when the elevator leaves the floor with the doors open. The rope gripper employs springs, a rotating shaft, and a stationary cam to obtain a mechanical advantage and apply a constant and equal pressure to the elevator suspension ropes. The cam action causes a changing mechanical advantage and is designed to compensate for any lining wear, providing a constant force on the elevator ropes even with the springs extended to less than half their original compressed value. An electric solenoid operates a trigger that prevents the springs from extending when the rope gripper is in the loaded, open operating position. But when the power source is cut due to electrical or mechanical malfunction, the springs will extend and the rope gripper is deployed. One brake shoe moves toward a stationary shoe which clamps the suspension ropes and brings the elevator to a smooth, safe stop. The brake shoes are designed with a lining material that prevents any damage from occurring to the ropes, but will still withstand many operations of the gripper. As the springs extend, oil is forced from a cylinder into a tank, which allows for a smooth, shock-absorbing type action. In order to release the gripper's hold on the elevator ropes, this hydraulic pumping unit is used. Oil is pumped into a cylinder, which extends a plunger that compresses the springs attached to a movable shaft, which then moves down the cam against the trigger. The rope gripper is now set and ready to deploy in case of an emergency. Watch the rope gripper in actual operation. Notice that the gripper shoes are open and the switch is closed, indicating to the elevator controller that the elevator can run up and down freely. If an overspeed condition exists, the governor overspeed switch will open, indicating an emergency condition. The power supply to the gripper is disconnected. This de-energizes the electrical trigger solenoid and releases the gripper. A switch on the gripper then opens, signaling the elevator controller to disconnect the power to the motor and brake circuits. The elevator car is brought to a smooth and safe stop when the gripper shoes close. When the overspeed switch is reset, the gripper power supply is established, and the gripper automatically returns from the activated to the loaded position. The contact then opens and disconnects the hydraulic pump. Upon reaching the loaded position, a switch closes, allowing the elevator to run. If the elevator leaves the floor with the doors open, contacts on the elevator controls will indicate an emergency condition, and the power supply to the gripper is disconnected. This de-energizes the electrical trigger solenoid and activates the gripper. If an overspeed condition activated the gripper, or the doors were open while leaving the floor, this indicates a problem with the elevator. In this case, reset will not be automatic. A technician would be required to investigate and correct the problem. If the gripper were activated by a power failure, it would immediately deploy. When power is restored, the gripper automatically resets itself. A malfunction of the car door contact or hoistway door interlocks presents another problem, indicating that the doors are closed when in fact they may be open. However, our sister company, GAL Manufacturing, has the solution in their patented fault monitor. The fault monitor detects faults from intentionally jumped or accidentally bypassed car door contact and hoistway wiring door interlocks, as well as shorted car or hoistway wiring door circuitry. This technology prevents the elevator from running, sounds the alarm bell, and holds the doors open. The GAL fault monitor was also engineered to be self-diagnostic, ensuring that both door circuits and the fault monitor itself are functioning properly. This unit can be easily installed on new or existing elevators. The fault monitor, working in conjunction with the rope gripper, offers the best available protection to the riding public. In addition, the rope gripper is also equipped with a manual pump, so that during an extended power outage, the gripper can be opened and the elevator car moved. This prevents people from being trapped inside the elevator car for prolonged periods of time. In order to operate this pump, a hydraulic valve must be closed manually. A switch actuating angle is removed from the gripper, preventing the elevator from running. This angle is then installed on the valve in the pump unit, allowing manual operation. When reinstalled on the gripper, this angle allows normal elevator operation when power is restored. In the unlikely event of excessive use, the shoe lining may wear so that the shaft extends to near the end of the cam, indicating that a new lining should be installed. We have provided a switch which will prevent resetting of the gripper and will not allow the elevator to run until the gripper is readjusted or new linings have been installed. Now, let's take a look at how easy the rope gripper is to install.
This video demonstrates the ease of installation of the rope brake, and in this case, we will be showing the installation of the Hollister Whitney Model 600 rope gripper. You will find written instructions packed with each rope gripper. Warning: when installing the rope gripper, 1. Make certain elevator is not running. 2. Keep hands clear of cables as forces can crush fingers. This video shows the rope gripper Model 600 being installed on an already existing overhead traction elevator. This particular installation has a machine isolation beam, which is already fastened to the machine beams. Other installation options are shown in the installation booklet. Your shipping carton should contain the following items: the rope gripper, which is used to clamp the ropes in an emergency and stop the elevator. You also have the pumping unit, which contains a hydraulic pump used to load the gripper, along with the instruction booklet. Mounting channels are recommended with rubber isolation between the machine bed plate and the gripper mounting. This framework is bolted into the machine beams, and the rope gripper is then mounted upon it. The framework supporting the rope gripper must withstand upward and downward forces of approximately 8,000 pounds. It must prevent sliding and be securely fastened to the machine beams. The geared machine must also be prevented from sliding. Mounting channels are available from Hollister Whitney or can be fabricated by the installer. Begin by laying the mounting channel in place so it aligns with the machine beams underneath the floor. Make certain that the ropes are centered on the mounting channel and then place the movable plate over the isolation beam. Mark the holes in the front and back of the mounting channel, making sure the front holes align with the isolation beam and the back holes align with the machine beams under the floor. Drill the holes through the isolation beam in the front and then through the floor and the machine beams in the back. Bolt the movable plate securely to the mounting channel. Then install the rubber isolation piece between the traction machine and the movable plate of the mounting channel. Next, loosely install 2 washers and bolts in the front of the channel, through the movable plate and the isolation beam, making sure the bolts go through the bottom of the isolation beams. Now, lift the rear of the mounting channel and install the washers and bolts through the channel and floor, making sure the bolts also go through the machine beams underneath. Before continuing, secure all mounting bolts to the underneath side of the machine beams and isolation beam with washer, lock washer, and nut. This assures the mounting channel is in a locked position and will not move during operation of the rope gripper. It is advisable to recheck the position of the mounting channel now that it is secured to make sure the ropes are still centered and that the mounting channel does not interfere with the rope operation. Now remove the back cover from the rope gripper. Remove the wire and hydraulic hose from their shipping position. Be sure the security set screws are in place, touching and holding the rotating shaft in the loaded position. Then, remove the 4 balance springs between the stationary and movable shoes. Now mark the top of the movable shoe. Mark the top and outside of the connecting arms on both sides. Next, remove the 4 snap rings and remove the connecting arms. Now, remove the movable shoe. The rope gripper is now ready to be placed on the mounting channel. Please note that the Hollister Whitney mounting channel has 4 pre-drilled holes to accommodate the rope gripper unit. If the channel you are using does not already have these holes, you will need to mark and drill holes before continuing. Now, loosely fasten the 4 washers and 1/2-inch bolts through the rope gripper angles to the mounting channel. Next, loosen the 3 angle bolts on each side of the gripper and align the gripper so that the stationary lining pad barely touches the ropes from top to bottom and from side to side. This is very important as a slight misalignment may cause uneven and excessive lining wear. Securely fasten the 4 1/2-inch bolts to the mounting channel and tighten the 6 angle bolts as well. Double-check alignment to make sure ropes touch the stationary lining pads evenly. Now, reattach the movable shoe, remembering the top-up position. Reconnect arms. noting top and outside position of right and left arms. Secure all 4 snap rings and reinstall the 4 balance springs. With the cover removed, find the best location for the pumping unit. It can be mounted on either side of the gripper, facing forward or backwards, right or left of the gripper. The electrical connection from the rope gripper may be attached to either side of the gripper and to either side of the pumping unit. Knockout holes on either side of the pumping unit allow the unit to be placed in the most convenient location. Secure the pumping unit to the floor by bolting it into place. Please note the knockout holes in the pumping unit, designed to accommodate the electrical connection from the gripper to the pumping unit, the hydraulic quick connect hose from the gripper to the pumping unit, and the electrical connection from the pumping unit back to the elevator controls. The wiring on the rope gripper may be changed by removing the green field and pulling wire into the gripper and out the opposite side. The wires from the rope gripper to the pumping unit are color-coded and should now be connected as follows: white, RG2, black, RG3, red, RG4, orange, RG5, blue, RG6, green, ground. Connect terminals RG1, RG2, RG5, and RG7 to elevator controls. Compare controller wiring diagram with gripper instructions diagram for proper connections. Before continuing, the shipping cap must be removed from the top of the pumping unit and the dipstick installed, or the unit may be damaged. The dipstick is shipped strapped to the inside of the pumping unit. With the wiring complete and the dipstick breather cap now in place, we are ready to connect the hydraulic hose by pulling up the ring around the female fitting while pushing the male fitting up until the ring can push down, securing the quick connect fitting. After wiring and hydraulic connections are complete, it is time to test the unit. Turn on the test switch located on the side of the pumping unit. The solenoid on the back of the gripper should energize and push down the trigger. If the solenoid fails to energize, check control wiring. Once the solenoid is working properly, turn the test switch on. The next step is to remove the security set screws. As you begin to remove the security set screws, if the rotating shaft moves backwards, it is necessary to operate the manual hand pump to put oil in the system so that the security screws are not holding the rotating shaft. If the arm does not move, the security screws may then be totally removed and stored in the pumping unit. If it is necessary to operate the manual pump, twist and pull up on the top of the valve stem. While pulling up, operate the hand pump until it catches and moves the shaft away from the set screws. These set screws may be removed and stored in the pumping unit. It is vital that the security set screws be completely removed, or damage may result when activating the gripper. Now it is time to test the rope gripper. Make sure the valve stem is in the automatic position and the test switch on the side of the pumping unit is turned on. Now the gripper is in the ready position and should not be clamping the ropes. To test the unit, turn the pumping unit's test switch off. This should activate the rope gripper and clamp the ropes. While the rope gripper is in the clamping position, a switch on the gripper wired into the elevator control prevents the elevator from running. The elevator should not run while the rope gripper is in the clamping position. Turning the pumping unit test switch back on will turn on the pump, close the valve, energize the trigger solenoid so the rope gripper is reloaded and should allow the elevator to run. It is now time for lining wear-in. It is important to clean the ropes from dust and dirt and excess oil and grease by running the car at slow speed from top to bottom. After cleaning the ropes, jump terminals RG5 to RG6 and run the car at a slow speed from top to bottom with the test switch off. The rope gripper will clamp the ropes with light pressure and the linings will begin to wear in. As the linings wear, the rotating shaft will move backwards in its slot, turning the corner, and begin to move up the cam. Once the rotating shaft has turned the corner, stop the car and remove the jumper from RG5 to RG6. Please note that the connecting arms move upward about ½ an inch during lining wear-in. There are 3 tests you should perform before the rope gripper is ready for operation. Test number 1. With the car traveling in the up and down directions and at a slow speed, turn off the pump test switch. The rope gripper should grab the ropes, stop the car, and open the control safety circuits, disconnecting power to the motor and machine brake. Test number 2. Once again, run the car at slow speed in both the up and down directions, and with the car outside the door zone, open the door lock circuit. The rope gripper should grab the ropes, stop the car, and open the control safety circuits. Now perform test number 3. At a slow speed, run the car in the up and down directions and manually open the governor overspeed switch. As before, the gripper should grab the ropes, stop the car, and open the control safety circuits. Note that during test 2 and 3, the control circuits may require a manual reset before the gripper reloads. The rope gripper is now ready for operation. We now know that the rope gripper activates when it is supposed to, and we will test it under actual overspeed and brake failure conditions. The first test is the power interruption test. Run the car in slow speed and turn off the test switch on the side of the pumping unit. This will activate the gripper, causing it to clamp the ropes and stop the car. When the gripper is activated, the elevator can run switch will open and signal the controls to interrupt power to the driving motor and machine brake. The next test is the ascending car overspeed test. While performing this test, do not allow anyone to enter or ride the elevator. With an empty car, overspeed the car in the up direction while keeping the machine brake open. The governor overspeed switch should open at 15% overspeed, activating the gripper. The gripper will stop the car before the counterweight strikes the buffer, or at least reduce the car's speed to the speed for which the buffer is designed. If it is impractical to overspeed the car, run the car up, empty at a high speed, with a machine brake held open, and manually trip the governor overspeed switch. The gripper will slow down and stop the car. The governor can then be tested to make sure the governor switch opens at 15% overspeed. Repeat with a full load in the down direction. Finally, the uncontrolled low speed test should be performed. Again, while performing this test, do not allow anyone to enter the elevator or ride in the car. With the car level at any floor and the door open the machine brake. With an empty car, the elevator moves up. With a full load, the elevator moves down. The gripper should apply within 500 millimeters or 20 inches of the floor level and stop the car within an additional 750 millimeters or 30 inches. Total travel should be less than 1.25 meters or 50 inches. If the car doesn't move when the machine brake is open, the brake drum can be turned to start the car. Now replace the covers on rope gripper and the pumping unit.
The rope gripper works on any cable elevator and can handle capacities of up to 10,000 pounds. We have designed a variety of different rope grippers to accommodate a variety of capacities. In the case of 2-to-1 roping, a 20,000-pound capacity can be achieved. For codes that do not require automatic reset, this rope gripper is manually operated with battery backup to prevent operation in the case of a power failure. One of the most reliable aspects of present-day elevators are the wire ropes. The likelihood of one, let alone all of the ropes at one time breaking, is relatively unheard of. In fact, the only known incident of a car falling due to rope breakage occurred in the Empire State Building in the 1930s, which resulted from an airplane crashing into the building and severing the ropes. But far more common are instances of elevators leaving the floor with the doors open, which can result in a very dangerous situation. There is little doubt that the rope-driven elevator is here to stay. Future innovations in the elevator industry will likely develop in the area of safety. The rope brake has created an impact on the entire elevator industry, helping to assure the safety of our passengers. At Hollister Whitney and GAL Manufacturing, we're dedicated to exploring new technologies and finding better ways to make sure every ride is a safe one.